Thank you to Blinkist for supporting PBS.
Now would probably be a pretty bad time for me to admit that I have a bit of a fear of heights. How tall are we here? How high up?
We're just at 30 meters now.
30 meters. So
High in the canopy of a forest in the Pacific Northwest, or out on the deadly plains of the Serengeti.
Right now, there's a lion staring at me. It's very difficult to talk to you.
Two places that probably couldn't seem more different.
We've just come upon a group of lions. And what I can only say is approximately 1/3 of a wildebeest.
Yeah, I've been at it.
Yet there's this incredible principle of life that ties them together. The thing is, to see it, you've got to stop looking at nature like this and start looking at it like this. Nature is full of drama and cuteness and beauty and just plain weird things. But what if predators and prey and plants are just really cool ways of moving nutrients, elements, and atoms around? What if that's the real circle of life?
Whoa.
I mean, I never really thought of it like that, but it makes sense.
I mean, I think about dead stuff and weird things all the time.
But like elements and chemicals and nutrients, whatever, you know, my one semester of chemical engineering in college says, yeah, that's cool, but doesn't it kind of take the fun out of everything to think of it as base elements just moving from here to there?
I don't think so, actually. Not if you look at it this way. Okay, so a couple episodes ago, we talked about how wildebeest make one of Earth's most dramatic annual migrations, right? As they travel up from these lush rainy season grasslands to their dry season refuge hundreds of miles to the north, 1.5 million wildebeest have to cross a seriously dangerous obstacle, the Mara River. So they mass up along the shores, just waiting, nervous, until suddenly, an avalanche of hooves descends into the river. It's chaos. The river itself is dangerous enough, but what's in the water is even worse. As the survivors make it ashore, the river is just littered with bodies. Some of those are from the crocodiles, but even more of them are from mass drownings. I just realized someone should invent like a wildebeest life jacket or something. It would make this so much easier.
It'd be entertaining when a crocodile gets one, though, because it'll just like whoosh, whoosh, whoosh.
I love this. Give me a front row seat. I want to see this for myself.
Every year, thousands of tons of wildebeest bodies are put into this one river. Now, that soft tissue decomposes pretty quickly, right? But half of a wildebeest's biomass is bones. And those take a lot longer to break down, months, even years sometimes. And locked inside of those bones are nutrients, stuff like calcium, phosphorus, carbon, nitrogen, elements that other organisms in the ecosystem need to grow. We're talking up to 50 blue whales worth of nutrients and biomass seeping into this river every year, and then flowing downstream to other parts of the ecosystem, where it might end up in, say, grass. Grass that could become another wildebeest. Every single ecosystem on Earth depends on cycles just like this.
Life is just atoms then, moving between living and non-living things, and maybe I'm just a collection of nutrients? I can't be the only one who's a little weirded out by this, can I?
I mean, I love this sort of thing. It's the death that drives everything else in nature. Joe, I need to see more of this dead stuff.
Coming right up. So back in the Serengeti, Jahawi and I set out to explore the shore of this waterhole. What I didn't realize is that what we found there would help tie together so many scenes of life and death we'd encounter on the rest of our journey.
One thing I was not prepared for was just how many bones there are just everywhere, and hooves.
I know.
These used to belong to somebody.
I mean, it's complete carnage over here. So you've got the lions, they'll take down the wildebeest and start eating. Now, depending on how much noise was made, that could attract hyenas.
So hyenas, they've got this reputation for being these vicious scavengers. I mean, they're always happy to take a meal from somebody else's gross leftovers, right? But I think they've gotten a really bad rap.
Yeah, thanks, Disney.
Boo! Hyenas are awesome!
They really are. I mean, they're social and highly intelligent creatures, right? And super successful predators in their own right. When they have one of the highest kill success rates of any carnivore. And not only that, they're strong enough and creative enough that they can even push lions off of a kill.
There is a lion and a hyena.
Lion and hyena. Wow. So we're coming up on lion and hyena.
A pride of lions has killed and eaten most of a zebra. And the smell of this kill has attracted a pack of hyenas. At first, the smaller hyenas are outnumbered. But soon, more arrive, and aware of their numbers or the lions' full bellies, they sense they may have the upper hand.
I think you mean upper paw. Eh.
Very, very funny, Graslie. Where was I? The hyenas make their move.
When they're getting excited now, you can see. So their tails will start to rise and look, they start falling.
The lions retreat, and the few choice prizes that remain are the hyenas to squabble over. But in the vicious competition for resources, at least one of them knows how to get ahead.
Whoa. Joe.
That's bad.
head.
That's bad.
Like a head.
No, yeah, we get it. We get it.
Not sorry.
There's not much left. I mean, imagine all those lions would have just eaten so much. And when the other hyena came in, they were literally scrapping for bones.
I've got the pelvis, you can't catch
Yeah.
me.
So back at the waterhole the day before, I noticed something kind of weird. That all the bones that were left there were just things like skulls and backbones and ribs. All of the long bones that were full of that delicious marrow, they were nowhere to be found.
Fun fact, maybe related, hyenas have a stronger bite force than any African carnivore.
I mean, I knew that because hyenas are sick.
And with that hyena's bite force, they can actually crack that bone and get into there, and they'll actually crush the bone and eat it. If you look at that, that kind of shows it straight through. So this is definitely hyena.
They can just digest the bone.
Yeah, their stomach is so acidic that it literally just breaks down the bone.
Wow. I mean, the sound that hyenas make, the way that they move, they are a little bit silly. But they have this incredibly important role out there in this ecosystem, cleaning up all of these kills. So anyway, when they were all finished, we headed over to see what was left.
Wow, that is pretty gross. There is nothing left except a big bloodstain in the Serengeti.
Yeah.
But even that will return back to the ecosystem. I mean, already
Exactly.
they're standing here. Like, I just saw butterfly land in this gory kill scene, but there's salt, there's water. I mean, there's so many levels of nutrient,
Yeah.
and there's an organism that's specialized for every one of them.
This just goes to show you just how many different species one kill can support. And that's why, you know, the plains aren't just littered with dead, rotting bodies. The smell is something.
Yeah. I could get farther away. How do you feel about breakfast?
I think it's about time.
Yeah. I'm hungry.
What do you eat after you see that?
Bacon.
I think it sounds pretty good.
You guys are weird.
So, okay, Joe, but hyenas aren't the only thing recycling all this dead stuff.
That's exactly right. There are a bunch of other animals who help recycle all these dead nutrients back into the ecosystem.
I mean, this is just crazy.
This is absolute chaos.
Yeah.
What you're hearing in the background, we've just come across a kill. Kind of hard to tell what's under there because there's like 100 vultures in a pile on top of what used to be an animal.
I mean, it's just this whole area is covered in vultures, and more have been coming in. I mean, they're like grumpy old men, all just arguing with each other. And the marabou stork looks like he's just presiding over the proceedings.
It's like the referee. Gentlemen, keep it clean.
A neat thing about vultures is they have a bunch of different names for groups of them. So vultures in flight, they're called a kettle. Once they land, they're called a committee. And then when they're feasting, that is called a wake.
Why do you know so much about vulture group terminology? You holding out on us?
It's no thanks, Joe.
Bald head, hooked beak. A vulture is basically made for reaching parts of a carcass that large predators can't.
So your bigger vulture species can sort of rip open skin and stuff like that. Your smaller ones will be really getting their heads in there.
In there.
In there.
Like
In there.
I mean, somebody's got to eat every part of this, right? So they've all specialized to get at every bit of nutrients that they can out of something like this.
This is the bird song in the Serengeti. The sound of screeching, hungry vultures.
Very musical. Musical the way that a garbage truck is musical.
When those vultures fly off into some tree and later, make a poo, well, that nitrogen and that carbon, even iron that used to be inside of that carcass, it gets dropped back into the ecosystem. But in this kill or be killed environment, there are still more bones left behind than these scavengers can clean up. But even those are broken down over months and years.
You've got different insects that can come in and start trying to break it down, and then also to the microbial level.
It looks like part of a backbone here, like a vertebra.
Yeah. I mean, there are minerals in here, and so once this bakes in the sun, it's going to start cracking. And when it starts cracking, that's when it can start releasing the nutrient. But the incredible thing is sometimes you find giraffe chewing on old bones.
I thought they only ate leaves.
Yeah, they do that to get minerals that they don't get from their diet, like phosphorus and calcium that's not in those acacia leaves that they love to munch on so much.
It's like a vitamin lozenge.
So weird. So weird. Anyway, weather and microscopic organisms take over, and eventually every part of this creature makes its way back into what I think is the most underappreciated and overlooked part of this entire ecosystem. I mean, it's right under our noses, or our toes, I guess. But what happens down there in the soil, I mean, it's literally the foundation of every terrestrial ecosystem. Take fungi, for instance. They live in these symbiotic relationships with the roots of plants. And so they feed the plants nutrients and help them get access to water, and in exchange, they get some of that fuel, the products of photosynthesis. Out in the Serengeti, fungi only make up less than 1% of all the living biomass, but they put back twice as many nutrients into the ecosystem as all of the animals combined. And microbes. I mean, the air is, 78% nitrogen? But without special microbes in the soil that convert that nitrogen into forms that plants can actually use, I mean, life on this planet as we know it wouldn't even be possible. And without dung beetles, I mean, the Serengeti would be literally knee-deep in you-know-what. Scientists once counted 16,000 dung beetles and other poop-eating bugs in just one pile of elephant dung. It was gone in 2 hours or less. And in just 100 meter by 100 meter square area out there on the Serengeti, dung beetles can bury more than a ton of poop every year. And termites! All the termites out there in the Serengeti probably outweigh the mammals, and they're burying just unimaginable amounts of dead plant matter down there in their underground little fungal farms and recycling that back into the soil. It's amazing. In a place like the Serengeti, there's so much drama and action and death happening up there on the surface. But what happens on Earth in a big way depends on what happens in the Earth. I just get really excited about soil sometimes.
The question I still have is, how do scientists study this stuff? Because, we don't actually have special goggles we could put on to let us see all the elements and atoms moving around in these wild places. And nature isn't a tidy laboratory environment. You can't put an ecosystem in a test tube and study it.
I mean, but what if you could? I just got back from visiting this really cool long-term research program in Oregon at this place called the H.J. Andrews Experimental Forest.
Wait. What, an experimental forest? Are the trees wearing lab coats, the tiny beakers swirling around? And
They're out there filling out lab reports and with goggles on.
Stop. If scientists want to study a system as complex and sprawling as a forest, they can't do that indoors. So they go to outdoor labs instead, like the Andrews Forest. Temperate rainforests like these in the Pacific Northwest are home to thousands of species. And a big question that scientists have is, how do essential nutrients, those elements like carbon and phosphorus and potassium, how do they get cycled through these intricate webs? I mean, it might seem less chaotic than the Serengeti, but the characters in this drama are the same. They're decomposers and scavengers.
As someone who's been to Africa one time, there's no hyenas in the forest, Emily, like doing the scavenging.
So I'm talking about mulch munchers and microscopic things happening down in the understory. But to understand all of that, we actually need to start up there in the canopy.
Is this our friend today? This is our friend.
That's my buddy Mark. He's the director of the Andrews Forest, and he's taken us up.
Wow, that's a tall tree. That's a tall tree. Most of these old Douglas fir in this stand are 450 to 500 year old.
Wow, that's amazing.
We've seen a lot of floods, a lot of fires.
They literally stood the test of time.
That's really high up. My camera can't even zoom in to the top of the tree.
Oh boy, this is gonna be fun.
This is the most awkward part.
I don't think anybody can make this step look cool. Now would probably be a pretty bad time for me to admit that I have a bit of a fear of heights. How tall are we here? How high up?
We're just at 30 meters now.
30 meters. I'm all right. We're gonna keep going up.
I feel for you. Heights can be scary, but why are we going up in the tree in the first place?
They want to understand how nutrients move from the atmosphere to the canopy and down to the forest floor. So you gotta start at the top. I mean, there's a certain kind of lichen called lungwort. It grows all the way up these trees and has a unique ability to pull nitrogen out of the air. So when the lichens eventually fall to the forest floor and decay, the nitrogen goes back into the system.
Lichens, I'm liking this.
Somebody put Joe on mute, please. Somebody.
Never heard that joke before. Okay, beyond just wanting to make a personal visit to see our cool lichen friends, it turns out that this tree is actually a tricked out science lab. It's got different instruments all up and down the trunk. So they're measuring things like rainfall, humidity, wind, tree stress, even things like microclimates that exist at different heights.
It's amazing what kind of life you find up there. And all the way up there, as high as we were, there were like tiny ants crawling on some of the cables for the scientific equipment. And to know that it just lives its entire life, literally 12 or 14 stories above the forest floor.
Okay, here's the twist. There's another key element at play in the forest, but you're not gonna find it on the periodic table. It's the element of time. And all of the forest vitality is fed by the slow decay of its life.
So early on, there became an interest in the Andrews Forest about the fate of trees that had died.
That's Dr. Mark Harmon, forest ecologist / tree whisperer.
We tend to think of a tree when it dies, it disappears from our mind, but it doesn't disappear from the forest unless we take it.
Yeah.
It can persist for a really long time as a home for organisms, as a place to get food, as a structure that affects the physical nature of the forest. And so there became this realization that dead trees could potentially be an important part of a forest.
I just realized I have no idea how long a tree takes to disappear. How do you even begin to study this?
Yeah, so in the 1980s, Mark and some other scientists started dumping cut trees in different spots in the forest. And they started measuring their shapes, sizes, and densities, and they kept going back, taking more measurements to see what was changing. They've been doing this for 40 years, and the experiment is projected to last until 2185, 200 years after it was started.
Whoa. But that totally makes sense. I mean, if things are happening so much slower here than, say, the Serengeti, I mean, this is the kind of study you're going to pass on to your grandkids, I guess.
Ah, yes, the age-old question. When the tree falls in the woods and nobody's around to document that event, how long do we know for it to decompose? That wasn't a sentence.
Exactly. It's all about decay. A live tree is home to lots of other organisms like birds and mosses and lichens that live on it. But in general, a tree doesn't like stuff living in it.
In this study, we're starting to look at the other part, the other life of a tree, which is when it's dead. So it has this thick bark because it's preventing all these organisms from growing in it. Now when it dies, those rules are off.
Free game. The mulch munchers.
The mulch munchers basically rule the world.
Love the phrase mulch munchers. It sounds like a squishy superhero group.
Mulch munchers, assemble!
They're the esteemed detritivores of the undergrowth, here to save the day. So these forest recyclers, they're not big, munchy things like hyenas. They're millipedes and molds, which, frankly, I think are even cooler. That's a fact. They have lots of weirder things, frankly.
Yeah.
Tell me more.
Like junk coming out of their heads, literally. Millipedes. Fourth leg segment is actually their genitals. Just in case you needed an extra fact.
I have several questions.
So how long do you think it takes a tree to decompose?
That's a good question. 20, 25 years?
I'm thinking a lot longer, like 70, 80 years.
You guys aren't even close. A Douglas fir might live for 300 or 400 years and take just as long to decompose. And species with super dense wood, like red cedars, they might live 1,000 years and then take another 1,000 years to decompose. They're naturally rot resistant, which is why people like to build stuff out of cedar.
It's impressive to think of all of the world events that have happened while this tree was growing here stationary. I mean, we've got world wars, civil wars, the European colonization of America, the Sistine Chapel being built and painted. And all of this is happening on our human time scale, completely different than the magnitude of this organism's life.
So the point is that things are happening, but they're happening slowly. And as a tree decays, scientists like Mark have broken it down into the 5 stages of log decomposition.
Decay is, and decomposition is a continuous process, but sometimes it helps us humans to think of stages.
Okay, so stage 1 is the first 5 to 10 years of a dead tree's life.
So if it's got the needles or all the fine twigs left, we might classify that as a class 1.
Okay.
And it will look kind of naked.
Stage 2 is the next 5 to 25 years, and water begins to seep into the bark, the wood gets soft, leaves and twigs are gone, and to test if it's a 1 or a 2, Mark uses a really sophisticated scientific technique.
It's a kick test, they say, call it. No, literally, and you can hear different sounds. It doesn't go thunk when it's sound. This is what we'd call a class 3 log, but we also see it starting to fall apart.
Oh.
So this has probably been down about 50 or 60 years to get to this stage.
Stage 4 is the longest, the next 75 to 200 years, and there's lots of stuff going on. The log becomes a decomposing petri dish. Plants and fungi move in, hundreds of species of invertebrates take up shop, insects, mites, slugs, snails, tiny mammals burrow in, salamanders. Oh my god, salamanders, they're the tigers of the undergrowth. They come in around, they're hunting everything, and of course, all of this stuff is pooping, and that becomes part of the nutrient recycling chain. I mean, you guys know I love a good poop story. But anyway, so finally, there's stage 5, which is sometimes 400 to 500 years after the tree's initial death.
500 years? I mean, this is wild. It's like when the Mona Lisa was being painted, a tree fell down, and now it's still in stage 4.
I mean, the reality is, like, I've been wanting to film at this place for so long, like, just because of this fact. Like, I found out that there are people doing a 200-year-long research study, and I was like, have I lost my mind? I didn't even know that was possible. Like, and then they're out there like, nah, it should have been 1,000 years, but we are gonna just cash it in early.
It's so nice. I feel like it's hugging me back. I'm gonna get ants on my face. This is how you get termites in your pants. Is that it? Is that
This was a Douglas fir at one time, and now it's a bunch of, well, actually, that's a scientific term for it, red mush. That's what we call it.
Really?
Yeah. And it's very ideal for roots. The reason we see all these roots is because it holds a lot of water. So it's kind of like a compost in that way. It also is releasing a fair amount of its nitrogen at this stage.
After this, it's returned to the earth.
Pretty much.
So over the course of maybe 5 centuries, a dead tree continues to give back to its forest. Nutrients, shelter, water, microhabitats for untold numbers of life forms. All of its elements are cycling back through the system. Even after being burned or killed in severe wildfires, forests continue to hold on to their stored carbon for decades, unless they're removed by salvage logging. But all of this only works if a tree stays where it falls. So when a tree falls in a forest, leave it alone. Even though it's dead, it's still doing really, really important work.
We can all hope to have such an impact after our own life.
Just dump me out somewhere on the side of the highway.
Okay.
just let me, feed a possum or something. I'd be so happy. After all of that talk of death and stuff, I wanted to go meet some of these little critters for myself.
So this is a really exciting find down here. We talk a lot about microorganisms in the forest, and here's a giant of the invertebrate world, although it doesn't seem that big. This is a millipede, a species of cherry millipede, and what's really cool about them is you see these lines of red alongside the body, and that's this organism's warning color saying, you don't want to eat me, I taste really bad.
Emily, why do they taste bad?
Cyanide.
Yikes. How did you find that out?
Oh, the hard way. Just kidding. It's a known defense mechanism.
Oh, these are one of the big cows of the undergrowth. This is a banana slug, and I hope you can get a sense of scale, but it's, 5 or 6 inches long. Making some pretty solid progress on eating some of this plant material. So these are just really cool organisms, moving at the speed of a slug.
Detritivores, like millipedes and slugs, might look tiny, but they've got a huge impact here as nutrient cyclers, turning dead plant and animal material into energy that can be used by so many other living things, including more trees.
So these log jams, although they look a little unsightly and, your instinct might be to move them out of the way, they actually create habitat and leach nutrients into the water that can support so many other aquatic invertebrates and vertebrates too. A temperate rainforest like this can support an amazing amount of life from the top of the tree down to the ground. But there's one other area that we haven't quite explored yet. This is hilarious. Oh, I feel like I'm being born again! That's really cool!
Even here underwater, in creeks and in ponds, that slow cycle of decomposition is still at play. There's snails and caddisflies, the browsers and the grazers, predators like the crayfish and the salamanders. Everything that gets washed into these streams will eventually get drawn back up through the roots of trees, through the soils, and the bodies of the plants and animals. It's a process that's been millions of years in the making, and hopefully will be repeating for millions more.
This is just amazing. I mean, you stick your head in and you see this entire environment, a whole ecosystem of animals that are calling this place home. It's all kind of happening here under the water, and it's just a mask in some time. You can see all of it.
I've never really thought of nature this way, just nutrients moving around and atoms. It's such a cool way to see the world.
I know, like an experimental forest is such a cool place. And I love that these processes that are happening there, we're also seeing them in places like the Serengeti, a place that couldn't seem more different on the surface.
Yeah, I mean, all of this decay and nutrient cycling, sometimes it's happening at scales big and small, sometimes very fast, and sometimes at a snail's or a slug's pace.
We would all like to thank Blinkist for supporting PBS. Listen, it can be hard to find the time to sit down and read an entire book, but now you can in the blink of an eye. Blinkist is an app that produces key takeaways from thousands of nonfiction books and then condenses them into 15 minutes that you can read or listen to. Blinkist has an array of categories for just about any interest, from science to history to self-improvement to parenting. For more information and a Blinkist limited trial, just check out the link down in the description.
Hey, get this, like, extremely about to explode rotten wildebeest stomach.
I mean, they've done well at not popping it.
Wow, this has got to be the most completely cleaned up kill I've ever seen. No bones about it.